Hi students, in this video we're going to cover types of conditional statements. Our objectives are to learn to write the converse, inverse, and contrapositive, and we're going to use symbols to represent those entire conditional statements. So a conditional statement is a statement written in the form if, then. Every conditional statement has a hypothesis. That's the statement between the words if and then. Every conditional statement also has a conclusion, and that is the statement after the word then. In this example, if x is an even number, x is an even number is our hypothesis, and the conclusion is x is divisible by 2. So the symbolic notation for a conditional statement is P arrow Q, which means if statement P, then statement Q. In our example, x is an even number. If x is an even number, then x is divisible by 2. X is an even number is the hypothesis, or that is statement P. X is divisible by 2 is our conclusion, or that is statement Q. So if the hypothesis, then the conclusion. So if P, then Q. So for this slide, pause the video and then underline the hypothesis and circle the conclusion. Restart the video to check your answers. The hypothesis for 1 is it snows tonight. The conclusion is school is canceled tomorrow. For number 2, the hypothesis is 2 lines are parallel. The conclusion is the lines have the same slope. For number 3, the hypothesis is a quadrilateral has 4 right angles. The conclusion is the quadrilateral is a rectangle. The first type of conditional statement we have is a converse. So if P then Q is the original statement, the converse is formed by swapping the positions of the hypothesis and the conclusion. If we have the statement, if x is even, then x is divisible by 2. X is even is the hypothesis. X is divisible by 2 is the conclusion. The converse is going to swap the hypothesis and conclusion so that we get if x is divisible by 2, then x is even. We can see that this is if Q, then P. On this slide, you're going to try to find the converse of each statement. Please pause the video, practice, and then come back and check your answer. For number 1, you should have gotten x equals 3 is P, 3x plus 1 equals 10 is Q. That's going to make your converse. If 3x plus 1 equals 10, which is statement Q, then x equals 3 is statement P. Notice how we just swapped the hypothesis and conclusion. For number 2, if tomorrow is Sunday, that is going to be statement P. Today is Saturday is statement Q. We get if today is Saturday, then tomorrow is Sunday. Notice how we again swap the hypothesis and conclusion. For number 3, if an angle is obtuse, then the angle's measure is more than 90 degrees. An angle is obtuse, statement P. The angle's measure is more than 90 degrees, statement Q. So we swap these again and we get if statement Q, then statement P. We don't underline then, I'm sorry. Still good. So the inverse is for the original statement P, if P, then Q. The inverse is formed by negating both statement P and statement Q. Remember, negating means do the opposite. So for our statement, if x is even, then x is divisible by 2. X is even is the hypothesis, statement P. X is divisible by 2 is statement Q, the conclusion. So our inverse statement is if x is not even, that is not statement P. X is not divisible by 2 is not statement Q. So we have this form, if not P, then not Q. On this slide, you're going to practice trying to write the inverse of each statement. You should write the inverse, pause the video, and check your answers. So for number 1, you have X equals 3 is statement P, 3X plus 1 equals 10 is statement Q. Our inverse is if X is not equal to 3, which is not statement P, then 3X plus 1 equals 10 is not equal to 10 is not statement Q. So again, that is, if X is not equal to 3, then 3X plus 1 is not equal to 10. That is our inverse. For number 2, if tomorrow is Sunday, the hypothesis is tomorrow is Sunday, statement P. The conclusion is today is Saturday, statement Q. Our inverse is if tomorrow is not Sunday, that is not statement P. Today is not Saturday is not statement Q. For number 3, if an angle is obtuse, then the angle's measure is more than 90 degrees. Statement P is an angle is obtuse. The angle's measure is more than 90 degrees is statement Q. Our inverse is if an angle is not obtuse, which is not statement P, then the angle's measure is not more than 90 degrees is not statement Q. So again, if not P, then not Q. The contrapositive for the statement if P, then Q is formed by swapping the hypothesis and conclusion and then negating the hypothesis and conclusion. So that's going to give us the form if not P, then if not Q, then not P. If our original statement is if X is even, then X is divisible by 2. Our hypothesis is X is even, and the conclusion is X is divisible by 2. So that's going to be if P, then Q. Then our contrapositive, I'm going to abbreviate contra. So the contrapositive is if X is not divisible by 2, that's going to be not statement Q. Then X is not even, that's going to be not statement P. So notice how we swapped the hypothesis and conclusion and then negated each one of those statements individually. So on this slide, you're going to try to write the contrapositive of each statement and then check your answers. So you should have gotten if X equals 3, that's statement P, 3X plus 1 equals 10, statement Q. So our contrapositive is going to be if 3X plus 1 is not equal to 10, that's not statement Q. Then X is not equal to 3 is not statement P. For number 2, if tomorrow is Sunday, then today is Saturday. Tomorrow is Sunday is statement P. Statement Q is today is Saturday. So our contrapositive is if not statement Q, then not statement P. If an angle is obtuse, then the angle's measure is more than 90 degrees. We have statement P. The angle's measure is more than 90 degrees is statement Q. Our contrapositive, if an angle's measure is not more than 90 degrees, that's not statement Q. The angle is not obtuse is not statement P. Notice how for each of these, our contrapositive is if not Q, then not P. So a quick recap is we want to match the statement with the correct symbolic format. So for the contrapositive, we get, let's take that back. So we want to not have that. We want an eraser. Let's take that back. So we want, let's do it in blue instead. So the contrapositive is if not statement Q, then not statement P. The original statement is if if P, then Q. The inverse is if not P, then not Q. And the converse is if Q, then P. All right. Thanks for watching.